Hey everyone, we are going to talk about this problem, question one on the um, worksheet that I gave out to you today. So you have a 34 kilogram stone on the ground. It's being pulled up by a rope. We know the tension, we know the angle, and we know the friction force. We have to first draw the free body diagram. So to do that, I'm going to start with the ability to just draw sort of the scenario. I want to understand what's happening. So I have my rock sitting on the ground. It has 34 kilograms, but I want to figure out how much weight that is because it's only 34 kilograms here. And to do that, I need to figure out, not 30, 34. I need to multiply mass by 9.8 to get the weight. So 34 times 9.8 is 333.2 newtons. So I have a weight, force of gravity, of 333.2 newtons. All right, so that's one force. I also have a tension of 250 at 30 degrees above the horizontal, coming from the center. So there's a force of tension of 250 newtons, where this angle is 30 degrees. Friction force acting on the stone, 23 newtons. Well, the block wants to go to the right, so I need a friction force counteracting that. It always acts perpendicular or parallel to the ground, so my friction force is 23 newtons to the left. Then I'm also going to have my normal force. So that's not really a free body diagram because I have this arrow here. We don't like having non-left and right forces acting. So I've got to change this arrow into an up force and an over force. And this one is called FTX, this up force FTY. So to figure out what FTX is, you look on your notes, you should have copied it down. Well, it's the hypotenuse of the angle, which is 250, times FTX is on the adjacent side, so that's going to be times cosine of 30 degrees, and my FTY is going to be 250 times sine 30 degrees. Well, sine 30 degrees I know in my head is 1/2, so that's going to be just 125 newtons. 250 cosine 30 is 216.51. So 216.51 newtons. All right, so now that I broke this arrow apart, I don't need it anymore. I don't want it. So I'm going to redraw my actual free body diagram to be this. Force of gravity, 333.2 newtons. One of my vertical forces, I have two. I have the normal force, which I'll get to in a second, and I have my FTY, all coming from the center, of 125 newtons. I have my FTX of 216.51 newtons, and I have my force of friction of 23 newtons. So I've got to find the normal force, and that's always actually going to be part B. Sorry for being overloaded, but I got to find, it says determine the value of the normal force acting on the stone, and I find the normal force because the total up force equals total down force, and my total up force is normal force plus 125. They're acting in the same direction, so they get added. My total down force is 333.2. So I got to solve for the normal force. Well, that's simple. Normal force equals 333.2 minus 125. 333.2, which is 208.2 newtons. So my normal force up here, I want to add in, of 208.2 newtons. So that's my free body diagram, and simultaneously I used information to find part B. So questions A and B are done. Last thing is we have to find the net horizontal force acting on the rock and the overall acceleration of the stone. So the net horizontal force, well, we already took care of the verticals. So the horizontal forces, you just have to do total to the right minus total to the left. My total to the right is 216.51 minus 23. This is going to equal, separate that, my F net X. Subtract those two, 216.51 minus 23 gives me 193.51 newtons. So I have 193.51 newtons. That's my total horizontal net force acting on the rock. It's my overforce minus my force of friction, which is going to allow me, I'm going to bring this down here. Sorry for all the confusion. Going to allow me to bring my acceleration horizontally, which is going to be F net X over M to be 193.51 over my mass, which is given to me in the top of the problem, 34 kilograms, which is 5.69 meters per second squared. And as drawn, it's going to go to the right, but you can just say horizontally. And that's it. So hopefully that helps. Find the free body diagram, break it apart, and use that information to find your horizontal net force. Use that horizontal net force with your mass, which was given, to find your horizontal acceleration. Thank you.